Saxon Math Course 2, Lesson 62. Today we're going to be doing something called classifying triangles, or learning kind of about what a triangle is and the angles that they have. Alright, so we're going to start on page 440 today. And if you look at 440, you're going to notice that there are three classifications of triangles, and I'm going to name them A, B, and C just to reference them. Okay, the first one right here is called an acute triangle, and really what that means is that the angle that is shown is less than 90 degrees. Okay, so here's a 90-degree angle, the little dotted line there. So it's less than 90, and this is about half, so I'm going to call that a 45-degree angle. That is acute. Okay? The 90-degree angle doesn't matter in what orientation. It could be a 90-degree angle this way, it could be a 90-degree angle this way, and it could be a 90-degree angle this way. Okay? Any quadrant, I showed the right quadrant here, that is a right triangle. It means that those are exactly 90 degrees without a question. Okay? C is called obtuse. Obtuse because it is greater than a 90-degree angle. So a 90 degree was here, right? But this one is a whole lot larger than 90 degrees. It went way beyond 90. Let's call that 135, and I'll show you why in just a second. Okay? So 135 degree angle is actually, if we make this the opposite of a 45 degree angle. In other words, this right here is worth 45 degrees, and we'll talk about some of the details here, but what you need to know right now is that it's obtuse. Okay? Three kinds of triangles. If we classify, it's either acute, right, or obtuse. Okay? And that's the first part of your lesson. Now, a couple things to note. We can draw an acute triangle, and get this. If this angle is acute, so will these. Okay? If we draw a right triangle, that means the two legs are exactly the same, or at least similar. Okay? That would look like the triangle would look like this. If it's obtuse, okay, so we're going to make this obtuse angle. It's going to be what's called a scalene, and we'll look at some other terms of how we name this one, but obtuse for now. Okay? All right. There is a right, and there is acute. Okay. I think you see that on your lesson. Let's go to the next page of 441. You're going to see a triangle that looks something like this. All right, and we're going to call this angle A, this B, and this C. All right, so what I've done is I've just drawn a triangle and I've named the angles, or named the every spot that a triangle has as far as an angle is concerned. Okay, it's just to orientate it. Okay, so if I want to say tell me what angle C is, well, angle C is equal to 90 degrees. How do I know that? Because of that little box. Okay, and if this leg and this leg are the exact same, I know that these two would be 45 degree angles. Now in the one in your textbook, it looks more like this. Right? It's a little bit longer. This is still a right triangle, so I know that angle C is still a 90 degree, and I'm going to guess on these two, okay, just for fun, but I would say that angle B is going to be a 60 degree angle, and angle A is going to be a 30 degree angle. Now the reason I said that is because there are some reference triangles that will be coming up called a 30, 60, 90 triangle, which is what we have, right? 30, 60, 90. And then there's also a reference triangle that's a 45, 45, 90, which is what we have here. You've got 45, 45, 90. Okay? This is a little bit beyond what the lesson holds today, but I just want to introduce you to some of these topics or these subjects. So let's look at the examples. Example 1. It says name the sides of the triangle in order from shortest to longest. Okay, so a couple of things that are really interesting about these kinds of triangles. It looks like they're exactly equal, okay? And they're named, all right? We have X, Y, W. And this one is 61 degrees, and this one is 60 degrees. Okay, so how do we know which one is the longest? Okay, well, a couple things that we need to remember. Inside a triangle, doesn't matter what triangle, doesn't matter what shape of triangle, could look like this, could be the obtuse one or the scalene. The inside angles, okay, degrees, equals 180 in every single triangle. Does not matter what triangle, okay? So that is the same for this one. So if I have 61 and 60, that totals to 121. That means whatever this angle is right here is 180 degrees minus 121 is going to give me 59 degrees. So I know that that angle up there is 59 degrees, okay? All right, so we're going to classify them from shortest to longest, okay? So let's begin. The first answer to this, the shortest distance, is going to be the angle XY. Why is this line right here the shortest? Well, let me take your attention to the angle here. What's the smallest angle? The smallest angle is 59, which means that if it's the smallest angle, it makes it so that this leg right here that I'm going to do in red is the shortest leg. So, classifying from shortest to largest, we're going to say XY, the line of XY. We could also say YX. It's saying the same thing. We're just reversing those things, okay? So that's the shortest. So let's start our answer over here. We're going to say XY with the line over it. In other words, that's the segment. What's next? Well, what's the next shortest spot here? Okay, it's going to be 60 degrees here. That means this right here is going to be the next, and we'll call this YW, which only leaves then WX as our longest. Well, why is WX the longest, you ask? Well, it's because 61 degrees is the largest, which means that it's the biggest angle, which means that this line has to be the longest to spread them out. Okay, I think you can understand that. So look for the smallest angle first. There's 59. You know that the opposite line is going to be the shortest. And then you're naming them. Okay, pretty simple. Let's go to example 2. Example 2 says, which sides of the triangle are the same length? Well, we're going to have to do some work in order to find that information out. So you start by drawing the triangle, and then we're going to name it the same as they name theirs, okay? And then we're going to put the angles in, and we're going to figure out the total angles. So here's 58 degrees. They give us 61 degrees, but we don't know this one, okay? So we do know that the total triangle equals 180 degrees. So let's add 58 and 61 and come up with our close to our add both those angles up, okay? And we know that it's 119, right? So 180 minus 119 gives us what angle? What's the number that we have here? Well, we have to do some subtraction, right? I'll do a little borrowing here, and so we're going to come up with 1 and 6. There's our number. Oh, well, look at that. There's a 61 degree angle, and there's a 61 degree angle. What does the question say? Which sides of this triangle have the same length? Which sides of the triangle? A side is the line. Notice Q and R make up this line. So my answer is going to be Q and R. Okay, so pretty easy. So which sides of the triangle are the same length? Well, this one is going to be similar. Let's look at the 58 degrees. Okay, 58 degrees means that it's going to project this at a 58 degree, this at a 58 degree, and a couple of things are true. In order to make this line the longest, okay, or potentially or exactly the same, this 58 degree and this 58 degree are the exact same sizes. So S and Q and S and R would be the exact same lengths, because from this 58 to here, this 58 to here provide this 61 and this 61 for that length. So here's our answer: SQ and side SQ and side SR. Not too difficult. I think you understand those concepts pretty easily. Okay, let's go to the next one. Example 3. Next page. Example 3 says this: in triangle JKL, and again they give a triangle here and they've listed the points on it, and it doesn't matter what you list these as, they're just picking random numbers or letters, I should say. It says JK equals KL, which equals LJ. Find the measure of J. Well, if they all are equal, each one of them equals the same thing, we have 180 degrees inside, and if they're all equal, we can just simply do this. We can say 180 divided by 3, which is going to give us 60 degrees. So if we did 60 here, 60 here, and 60 here, those all equal 180 degrees. So my answer is 60 degrees. Okay? Not too hard, pretty easy when it comes to those things. All right, when you have a triangle that has exactly the same lengths of legs, it's called an equilateral triangle. All right, and you'll see that blue term on the bottom of page 442, and I think that's a pretty easily understood concept. If the triangle has 3 different lengths, like this one, it's called a scalene. It's obtuse, but it's scalene. SCALENE. It means it has 3 different side lengths. None of these are the same. Okay, and I put tick marks to show that this is the longest, this is the second longest, this is the shortest. Okay, this one has the tick marks that say it's exactly the same. Sometimes you'll see tick marks that are only, instead of putting 2, if it's equilateral, they'll just put 1 showing it's all the same. Okay, if they're different, you'll see an arrangement that looks much more like this. All right. Okay. Let's do one last thing. Okay, so example 4 says the perimeter of an equilateral triangle is 2 feet. How many inches long is each side? All right, first of all, they say equilateral means all 3 are total, and it says it's all worth 2 feet, the perimeter. This plus this plus this is 2 feet. Well, how many feet is inches is 2 feet? It's 24 inches, right? So if we know that we have 3 sides, we can divide 24 by 3, and we know that's 8. So that means this is 8 inches, this is 8, and this is 8. 8 plus 8 plus 8 is 24, which equals 2 feet. So our answer, each side is worth 8. Pretty easy concept. I think you'll be fine in doing this lesson. If you do have any questions, please don't hesitate to ask.